In this video, we will solve a classic temperature and resistance problem and build strong intuition along the way. The question says, a platinum wire has resistance R sub 0 equal to 100 ohms at 0 degrees Celsius, and R sub 100 equal to 139 ohms at 100 degrees Celsius. Find its resistance at 50 degrees Celsius. Before we calculate, let's build intuition with a simple picture of the wire and a thermometer. Platinum's resistance increases almost linearly with temperature over this range. So at 0 degrees, the resistance is lower, and at 100 degrees, it is higher. We will use that linear behavior to predict the value at 50 degrees. In metals over a modest temperature range, we use a linear model. R of T equals R sub 0 times the quantity 1 plus alpha times T. Here, R sub 0 is the resistance at 0 degrees Celsius, and alpha is the temperature coefficient of resistance, measured per degree Celsius. We already know 2 points of this line. At 0 degrees, the resistance is 100 ohms, and at 100 degrees, the resistance is 139 ohms. Plugging 100 degrees into the model gives R sub 100 equals R sub 0 times the quantity 1 plus alpha times 100. Now we can solve this for alpha. Alpha equals R sub 100 minus R sub 0 divided by R sub 0 times 100. Numerically, that is 39 divided by 10,000, which equals 3.9 times 10 to the minus 3 per degree Celsius. Now, we find the resistance at 50 degrees. R sub 50 equals R sub 0 times the quantity 1 plus alpha times 50. Substitute the numbers. 100 times the quantity 1 plus 0.0039 times 50. That is 100 times 1.195, which equals 119.5 ohms. To solidify the idea, let's view resistance versus temperature as a straight line. We will plot 2 points, 0 degrees 100 ohms and 100 degrees 139 ohms. A straight line through these points represents the linear model. Halfway in temperature, at 50 degrees, we read halfway in resistance between 100 and 139, which lands exactly at 119.5 ohms. Back to the physical picture. At 50 degrees, the thermometer is halfway up, and the resistance has increased from 100 to 119.5 ohms. Summary. When resistance varies linearly with temperature, we can write R of T equals R sub 0 times the quantity 1 plus alpha T. Using the 2 given data points, we solved for alpha, and then found R sub 50 to be 119.5 ohms. This linear model is an excellent approximation for platinum over this range.